أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum to everyone. Our today's video-based lecture is about measurement in statistic of continuous variable, types of measurement, and then we will be discussing significant, non-significant digits, the zeros, when they are considered to be significant and when they are considered to be non-significant, and then the roundup. So let me share you the slides first, and then we will be discussing inshallah one by one. So continuous variable can never be measured with perfect fineness. Like for example, perfect fineness means like if you measure a digit and it gives you an infinite digit, 0, 0, 0, 1, 2, 3, and so on. So that is infinite measurement. You can't do this because it will take, it will occupy a lot of space. It will, waste your a lot of time. So what do? We go up to certain extent. After decimal, we either take 2 digits or 3 digits as far as the importance of the variable is concerned. So that is perfect fineness. So we can't go for perfect fineness, though they exist. Like for example, the measurement are recording nearest to the true value. The true or actual value assumed to exist. Degree of accuracy is a general rule. The degree of accuracy is half a unit each side of the unit of measurement. Like for example, if we measure weight, what do? If it comes 2.53987 or something like that, what do? We just go up to 2 digits after decimal for our convenience. We can go ahead. We can take so many digits, but we have to make it round up and we go just for 2 digits after decimal so that it is convenient for us and it is, as general measurement, we go up to 2 digits. We can go like as I have told you that it is infinite. You can go ahead up to so many digits, but you have to make it round up for your own convenience, and we go up to 2 digits. So we have to make it round up to this digits, and we will see this digit whether it is 5 or more than 5. So if it is 5 or more than 5, we can add 1, 2.53, and the rest of the digits we leave it. Is half a unit each side of the unit of measurement. Another example of this is like for example 2.5 half a unit, 3.5 half a minute, or 7.5 and something like that. Half a unit each side the unit of measurement. Difference between the true value and the measure value, it is called absolute error. The difference between the true value and the measure value is called absolute error. For example, if the true value is 2.538 and your measure value comes 2.537. So there is a difference of 0.001, and this is called an absolute error. That is called an absolute error. So if the actual or the true value is like this and your measure value came out to be this. The difference is equal to 0.001, and this is called an absolute error. Absolute error divided by true value is called relative error. Absolute error divided by the true value is called a relative error. For example, if the true value is 2.5, 3, and 8, and your absolute error divided by true value is equal to relative error. It means that if you have this true value and your absolute error is 0.001, so this is what called the relative error. This is called the relative error. A relative error multiplied by 100 is equal to percentage error. When the relative error, the absolute error divided by true value, that is relative error, and this relative error when multiplied by 100, that is called the percentage error. For example, this one is your absolute error, and when you multiply it with 100, either this side or that to this side, then whatever comes in your hand, that is called, whatever the value comes in your hand, that is called a relative error or percentage error. That is called a percentage error. So that is the difference between absolute error, relative error, and percentage error. And absolute error, what do we do? If we know the true value, the actual measurement of a value, and when we measure something and it has got some value whether above or below it, and you subtract this from the true value, that will be called as a relative error. And when you multiply this relative error into 100, that will be called as a percentage error. Significant digits. The significant digits in a number are those that represent accurate and meaningful information. Non-zero digits are always significant. With zeros, the situation is some more complicated. Zeros are significant if they follow a decimal point and conclude a number. Zeros are significant if they follow a decimal point and conclude a number. Zeros are always significant if it is placed between other significant digits or non-zero digits. Zeros are non-significant if they follow a decimal point but do not conclude a number. Zeros are non-significant if they follow a decimal point but do not conclude a number. Trailing zero in a whole number with no decimal shown are not significant. Writing just 540 indicate that the zero is not significant and there are only two significant figures in this value. Over here, if there is a decimal, 540 point or decimal, then all these threes are significant digits and the zero is considered to be a significant one. But if there is no decimal point after zero, then this zero is considered to be a non-significant zero. Trailing zero in a whole number with the decimal shown are significant. Trailing zero, those zeros which are following a number in a whole number with the decimal shown are significant. But there is a decimal, like for example, if this is a whole number 2.53.000, all these zeros are significant because they follow a decimal number, a decimal point. So all these are significant zeros. Placing a decimal at the end of a number is usually not done. By convention, however, this decimal indicates a significant zero. For example, 540 point indicate that the trailing zero is significant. There are 3 significant figures in this value. If you remove this decimal point, then there are only 2 digits which are significant, 5 and 4, and the 0 will become non-significant. But over here, if you put a decimal, naturally, if you think that at the end there will be a decimal, then the 0 will be considered a significant 0. 3 significant figures in this value. Trailing 0 to the right of the decimal are significant. Trailing zeros to the right of the decimal are significant. There are 4 significant figures in 92.00 or a point. For a number in scientific notation, n into 10 raised to exponent, all digits comprising n are significant. The reason is, although they come after the non-zero digits, they are said to be, if there are no decimal, they are considered to be non-significant. But the reason is, in such a scientific notation, all these zeros are considered to be significant. This is an exception. And the reason is we can go for infinite measurement in such a type of scientific notation. All non-zero digits, for example, 3.243, 2.11, etc. All zeros, all non-zero digits, for example, all these are significant digits. All zeros between non-zero digits, for example, 303, this is a sandwich 0, so it is considered to be a significant. Ending zeros when come after decimal, for example, 2.300, 2.40, 2.000, all these are considered to be significant. Initial zeros or leading zeros are always insignificant. For example, 0.0034, there are only 2 significant digits, and 00789, there are only 3 significant. The 2 zeros and these 3 zeros are considered to be non-significant. Power of 10 is insignificant. For example, 2.10 raised to the power 30 or something like that, that is considered to be insignificant. And if it indicates a scientific notation, then it becomes, then all the zeros become significant one. Is, for example, in the Avogadro number, if it is 10 raised to the power 23 or something like that, so all 23 zeros are considered to be significant because it indicates a scientific notation. Pure number, constant, for example, Avogadro number, or pi, if the measurement is not given, then infinite, and if the number is given, then all are significant. So over here, this is an exercise 20.000. There are 5 significant digits, and all these zeros are significant. The reason is there is a decimal point. The 0 comes before, and the trailing zeros after the points, they are also considered to be significant. Over here in the second digit, 0.012001, these 2 are sandwich zeros, so they are significant, and these are leading zeros, so they are considered to be non-significant. 89680, this 0 is significant because it comes after the decimal point. 3.0800, all these are significant digits. 0.00418, these initial zeros, the leading zeros, they are not considered to be significant. Over here, these 3 zeros are not significant, and this 1 0 is not significant, and this 0 is considered to be significant because it comes after the decimal. 6.320, this 0 is significant as there is a decimal point. 23.023, this is a sandwich, so this is significant. 0.0003, all the 4 zeros are leading or initial zeros, so they are considered to be insignificant. 2.1 into 10 raised to the power minus 3, all the power, the exponent zeros, which are 3 in number, they are considered to be non-significant. Only they are considered to be significant when they shows or indicates a scientific notation. 201, this 0 is significant because it's sandwich, and 600.00, all these are significant because these two zeros before decimal point and after the decimal point over here, they are not the initial or leading zeros. They come after 6 and there is a point. So all these 0.8001, the two zeros are significant while this zero is non-significant. Doubtful or uncertain digit. The last digit in any measurement is doubtful because if you measure something and that came to be 2.30, it may be 2.31 or 2.32. So over here, in this example, the first digit is accurate digit, whereas the second digit to the right of the decimal is doubtful. Like it may be 1, it may be 2, it may be 0. So the significant digits are all the accurate and the first doubtful digits. The first is the doubtful digit. So over here, these two, 2.3, they are significant digits, but 1 over here is 2 and over here is 0. These are uncertain. These are doubtful digits. Rounding up a number, rounding means making a number simpler but keeping its value close to what it was. Mean that a certain digit counted from left are to be retained and the last few digits are to be dropped in a decimal number. Replace with 0 in case of whole number. Here are the example. Rules for rounding up decimal numbers are as follows. The last significant digit is increased by 1 if the first digit of the remainder to be dropped is 5 or more than 5. Let me give you an example. For example, 2.56 and 7. If you want to round it up to 2 digits after the decimal, you have to remove this 7 by increasing 1 in this digit. It will become 2.57. What is the reason? This 7, if you want to remove this one, you have to look into it, whether it is 5 or more than 5. If it is more than 5 or more than 5, you have to delete and you have to add 1. You have to increase this digit by 1. So it will become 2.57. The last digit remain unaltered if the first digit of the remainder to be dropped is 4 or less. Now in another example, let me give you an example. 2.53 and 2. If you want to go up to 2 digits after the decimal, you have to remove this one. Now look at this digits. If it is less than 5, you have to remove this one and remain this unaltered. So it will become 2.53. When the digit to be dropped is exactly 5, then the practice is to increase the last significant digit by 1 if it is odd number, or leave it unaltered if it is an even number. So for example, when the digit to be dropped is exactly 5, then the practice is to increase the last significant digit by 1 if it is odd number, or leave it unaltered if it is an even number. For example, I'm giving you an example, 2.76 and 5. If you want to remove this 5, if it is exactly 5, then you have to look at this digit. If it is even, and of course this is even, you have to remove this one and you have to keep it unaltered. So it will become 276. Now, if it is like 2.775 and you want to remove this 5, look into this digits. If it is an odd number like a 2.735 or 2.795, then what you have to do, you have to remove this one by increasing 1 in this digit. So this will become 2.78 this will become 2.74, and this one will become 2.7, almost like, for example, if it is, if it is 5, then it will become 2.56. So this is what it means. For rounding up whole numbers, individual pieces of information, data, primary data, data that have been originally collected, raw data, and have not undergone any sort of statistical treatment. Secondary data, we will be doing some that is given in exercise, so we'll be doing it later on. The whole number, how to round off the whole number. Individual pieces of information, primary data that have been originally collected and have not undergone any sort of statistical treatment. Secondary data that have undergone any sort of statistical treatment at least once. Direct personal investigation, that you can collect the primary data. Collection of primary data may be direct personal investigation. Investigator collect the information personally, go to the field, the individual are the sample persons, and collect data from them. The advantage of primary data is information is quite accurate and complete. The disadvantage is costly and time consuming. In indirect investigation, third parties are witness having information are interviewed. So that is the indirect investigation. And that is also a primary data. Questionnaire, any inquiry form consisting of pertinent question with space for entering the information asked, that is a questionnaire. Collection through enumerators, here trained enumerators are employed to assist the informant in making the entries in the questionnaires correctly. So these are called enumerators. Local sources, no formal collection of data, but the local correspondents are directed to collect and send the required information on the basis of their own judgment. Like, for example, the correspondent or the reporter of a particular channel or newspaper. They are the local sources where they can collect the data through their own judgment. Computer interviews, respondent enter the data directly into the computer in response to questions presented on monitor. Secondary data, internal secondary data sources, data collected within the organization itself, such as reports and accounting records. External secondary data sources, publication of Ministry of Finance, Food, Agriculture, Industry, and Labor. These are self-explanatory. And if you have any question or any query that you do not understand or your concept is not clear, you can write in the feedback. State, Bank of Pakistan, Railway Road, District Councils, publication of Trade Association and Chamber of Commerce, research organizations such as universities, all these are secondary sources of data. Editing of data, in case of primary data, intensively check at an early stage in order to locate incomplete or inconsistent entries. The primary data, especially in qualitative research, are filtered. They are in the form of verbatim, and then you have to refine the data by filtering all the unnecessary information. You are filter those information are deleted. In case of secondary data, one should examine the reliability of data, accuracy, and scope of inquiry, whether the data is reliable or not. How do you know whether this data is reliable or not? It depends upon the researcher or the investigator. If he or she is qualified in that particular field and has collected the data, then it becomes a reliable one and do have the experience in that field. Accuracy and scope of inquiry. So that you have to check for it. Thank you very much. This was a short lecture, and